I'm going to start recording now, so we'll get right to it. We only have 90 minutes, and always at the end of the 90 minutes, I am wishing that we had more time. So I will share my screen. We'll get to it. Feel free to stop me and ask questions or contribute at any time. And yeah, we'll work through this. When we finish this chapter 2, we're actually going to look for a project that we could work on together just so we can implement this thing as a group. And we do have a couple people who do come to every session, like Ken and Aditya, JH. We are starting to discuss just some of the project ideas that we could potentially do. So if it does become something that you like and you come back to, you're definitely welcome to join us on the project that we're working on as well. But if you can't see my screen, feel free to just double click on my name. If you double click on my name, you should see the screen. Or if you click on machine learning, the channel that we're all in, you'll see all of our boxes, and one will say watch stream, I believe, and that will be my stream right there. So let me just make sure no one else is trying to get in. Cool. All right, so we will get to it. I'm just going to give you a little sneak peek of where we are so far. Let me just run all. So we imported some housing data here. You can see the data here. This is the head of the data, just so you can get a sneak peek of it. Housing info is going to show you all of the attributes and how many are actually available within the data set. You could zoom in on certain attributes and just see more details about them. You could also describe is going to give you some statistical information. We're using Matplotlib for visualizations. So we split the data into training and test sets. This was like a less reliable method for doing that. Then we started going through more reliable methods, more consistent, and then we ended up using Scikit-Learn to actually create a training and a test set. We went and started manipulating and exploring the data, visualizing it. You can see it's the state of California, so we're looking at real estate data from the state of California. Here we create a scatter plot that gives us a little bit more information, like the population and the median house value. Here we're just visualizing to see if we can find any relationships in the data. We found a linear relationship in the median income and the median house value. Then we drilled in a little closer on this one where we saw the relationship, and we started seeing some outliers, some thicker lines, like some data that might interfere with the data set. We started looking for correlations. We actually created some new features. We created rooms per house, bedrooms ratio, and people per house, and we did find a negative correlation between bedroom ratio and median income or median house value. So looking for connections between positive and negative correlations between different attributes. Then we went and we started transforming data with imputers and transformers. We went through a couple different methods of, like, quote unquote normalizing data with one hot encoders. Let's see, transform, all basically doing the same thing, transforming data. Looks like that one I was having trouble running yesterday. All right, and then we just finished yesterday by just like looking at this data set. The last thing we did was we got the coordinates of San Francisco. We passed in the coordinates into a function transformer. Then we figured out, we converted each attribute, or each each basically property in the data set to like how close it is to San Francisco. So this one is obviously super close. This one is not. This one's further. This one's close. This one's further. So starting to do some interesting stuff with data. And yeah, so where were we? Is this where we left off yesterday, Ken? I think Ken is the only one who was here yesterday. Yeah.
We were looking at the custom transformers for I think if you go down a little bit more, going, yeah, right there, custom transformers.
Linear regression. But I didn't actually type this code yet. I don't think I typed this code yet either. Yeah, I did.
Oh yeah, you did.
Right there. Okay, cool. And then the RBF transformer with the age symbol.
I think that one's further down.
Oh, yep. Okay, cool. Age symbol 35, SUP coordinates. All right, so we left right here about then. Okay, cool. All right, so I'll go ahead and just continue reading. Does anyone have any questions before we get started? Feel free to, I'm going to go ahead and share this. Just so you could either...
One question.
Yeah.
Are you working in Jupyter Notebook now instead of PyCharm?
Yes.
Okay. No.
Yep. Yeah, I just shared the Jupyter Notebook too if you want to go ahead and follow along or type code along as well. Most people are typing code along with us just to get that muscle memory and actually type it out. Yeah. So, all right. So custom transformers are also useful to combine features. For example, here's a function transformer that computes the ratio between the input features 0 and 1. So it looks like we have a function transformer. We're passing in a lambda function with some computation here, and then we're passing in the array. Okay. Computes the ratio between input features 0 and 1. So it's computing the ratio between, if we look at our features, this would be talking about latitude and longitude, right? Correct me if I'm wrong. I'm going to go ahead and type that out. Feel free to type along as well. Or chime in if you have more information about what I just said. It just says feature 0 and 1. And if you look at the data set,
Oh yeah, so that print attitude.
Oh, okay.
We were just exploring the data. So.
So input features 0 and 1 are just column 0 and 1.
Yeah, they're just columns. Yeah. So it will just give you the coordinates.
What did I do here? Okay, cool.
Just as you guys know, the lambda function is just basically a function that takes an expression. So it just takes an input and then returns an output. So you see the lambda x, it's just x would be your input, and then an expression is just your output.
Okay. 0.5, 0.75. Function transformer is very handy, but what if you would like to transform to be your transformer to be trainable? Learning some parameters in the fit method and using them later in the transform method. For this, you need to write a custom class. Scikit-Learn relies on duck typing. So this class does not have to inherit from any particular base class. All it needs is 3 methods: fit, which must return self, transform, and fit transform. All right, so we've discussed these 3 functions a little bit. It sounds like every transformer is going to require these 3 functions here.
We want to go back to that lambda and like say what it does. Like it's the latitude is divided by the longitude, but
Yes, it's just giving you a ratio. So
and that
yeah, go ahead.
the colon part of it, what's that doing there? And not the first colon, but the x, bracket.
Right, the colon is it's just iterating. It's just iterating through the the whole list, and then it's just getting like the first element. So you see the index of 0. So it's getting the very first element. So it's just iterating through the whole list, and then getting the first element within that list, and then dividing it by yes. Go ahead.
So the end result of this lambda part is like the entire column of data of
Ratios, yeah.
Latitude divided by longitude, for example, and then that has whatever it's called, a series or column, then gets fed into the function transform that does whatever that does.
Yeah, you can say, yeah, it's basically just for each element within that whole data set, we're just saying, hey, we want a ratio, we just want the ratios of
The thing that I didn't know was the colon means that you're dealing with the entire column.
yeah, like iterating.
So you can get fit transform for free by simply adding transformer mixin as a base class. The default implementation will just call fit and then transform. If you add base estimator as a base class and avoid using args and kw args in your constructor, you'll also get 2 extra methods: get params and set params. These will be useful for automatic hyperparameter tuning. For example, here's a custom transformer that acts much like standard scalar. So let me just see something real quick. All right, I'm gonna type these out just so I have a reference to these in my notes. Feel free to go ahead and type this out so you have it as well. I don't think we're using this though, so let me see. Actually, yeah, we are. Okay. All right, so feel free to type along and add some comments if you would like. Standard scalar clone. So we actually have to write our own versions of this function in here to get it to work as well. I'm going to dig into this a little bit more later.
The relevance here of it saying this one you don't pass in multiple arguments or keyword arguments, I guess, as opposed to the one that came before this.
That's a good question. While I type this code, why don't you do a Google search on that? Yeah.
What I'm looking at least on the screen. So the fit is going to take in the, I guess, the X column data.
Yeah, so
This
this
X and Y like a graph we're talking about here.
so the X is like another way of saying that you're working with, I believe, wait, let me just search this up. I think it's like the test data set or the training data set. Let me check this out. Is X training or test data set?
Oh, here we go. Right in the comments on the line, it says check that X is an array with finite. And Jim, when you get a chance, you can scroll over a little bit. See the end of that sentence. I know it might say what Y is too.
Up or down?
In that the section of
Oh.
it has a little scroll bar there. Okay. X is an array with finite float values. So it might be X is just one of the columns of data.
Yeah, it's just a data set. And then Y is another like form of a data set as well, I think. I think Y is basically what you're predicting.
I mean, my first inclination is that we're talking about a graph of the data where it's, the X is the X axis and the Y is the Y axis, and there's even the word axis in here. So it makes me think that's what it's talking about.
Yeah, we can look at what X is after, cause like
The capital X is the entire data set.
yeah, it is, yeah. And then Y is basically your what you split
Is the Y is the label.
the labels, yeah.
Yeah. Yeah, so X is the matrix, and Y, I believe, is just an array with the labels. So like, if you look at my code down here, let's just say we're doing X25, that would be like feature 1, feature 2, feature 3, well, attributes. So you'd have like longitude, latitude, median house value, population, or whatever. So, but if you did Y25, it would just be like the label for that particular match in the data set, essentially.
Right.
So the fit function is going to take the entire data frame of data, and Y can be none, and it's going to fit it. I'm talking this out, but jump in when you want to correct me here. What is this doing?
What are you asking? What this class is gonna do?
Well, I guess you might say that, or even what the fit function will do.
So you could easily just type that right into ChatGPT and you'll get an explanation. So I would say if we encounter anything where you're like, I have no clue what this is, there's probably other people who have no clue what this is. So just do a search. Cause
yeah,
yeah,
I mean,
yeah.
I'm also trying to, as you're typing, I'm sort of filling up the sound waves.
Do you have access to the book? I'm just curious. I wonder actually.
I do.
Okay, cool. Yeah, I wonder how many people. Go ahead.
I have this on full screen, so I'm kind of not wanting to jump around, just because I like to sort of stay on this.
Agreed.
But, yeah, I could search stuff up.
Yeah, I want to take some time to like periodically I'll jump in and I'll just like standard scaler. I'll just like throw that in a Google search for later. Like I don't know. Sometimes I just throw like random stuff if I encounter words where I don't know. Just so I could like do research later on too, because I like to slow down, and so like obviously typing the code is great, and then like digging into the actual code, like what is this doing, is really good, and it's important for people to understand what's going on with that too. But the vocabulary is just as important too. So like as we go through and read this code, if anyone sees any words where they're like, what is automatic hyperparameter tuning?
Yeah.
Feel free.
Basically, yeah.
Feel free to just do like a Google search and like try to figure out what this stuff is too. Because if you're wondering what this stuff is, I guarantee there's someone else who's wondering what this stuff is too. So we have a few people in here who probably
Yeah, so from what I've gathered, it's what we're basically doing is we're transforming the data set to make it even more like easier for the model to learn, and that's why we're something called standardizing the data set by like zooming in from the data set to make it like be in some range of values. That way the machine learning model can like learn a lot better. That's what we're basically doing.
Standardizing is like taking from crazy numbers and making them from like 0 to 1, maybe
Yes.
negative 1 to 1.
Yes.
Yeah.
Exactly. Yeah, so from like, but it can be like in any range too, so it could be like from like 0 to 10. The process of what you were talking about was something called normalization, which is like putting a probability distribution for your set of values. So what standardization is like working with any range that makes it a lot more reliable. That way you can work with outliers as well.
Yeah, so there's some classes, we spoke about that yesterday. There's some classes that are going to normalize the data within a range of 0 to 1. There are also some that will normalize the data within the range of -1 to 1, which decreases the chance of outliers interfering with it, I believe. So there's different ways that you could normalize the data, but then there's some that are not going to normalize it within the range of 0 and 1 or -1 and 1. It's going to be just like, it could be like 6 and 10. It could be like 100 and 500. Like it depends on the method that you're using. But essentially what you're trying to do is you're trying to squeeze all of the data into a smaller range. Essentially, that's what I got from it. But I could be wrong.
No, you're right. You're right.
Okay, cool. And what I'm getting from this is just that, like I'm not like, yeah, I'm typing the code and I'm getting the muscle memory and all that stuff too. But what's really standing out to me here as I type out these custom classes is just that you can create custom classes. And when you create custom classes, the custom class must contain a fit method and a transform method.
Yeah,
So
so
that's
basically like, what is it? Overriding, or is it or is it like method overriding? Uh, I think that's accurate enough.
yeah.
Something to do with that, or method overloading. I'm not sure.
Yeah. I've heard of that before. Is that exactly what we're doing here?
It seems like it. 'Cause we're doing a fit method and a transform method, and it's basically generalizing like custom transformers, such that we can use a fit and a transform method and just call it.
It's overriding.
Yep.
Yeah.
So overloading is basically you use the same name function, but different parameters, or like
Right.
number of parameters. So when it comes to class, basically you define multiple classes and you define the same name, same parameter function. But when you create an object of whichever class, it will call that function.
Yeah.
Instead of calling its original version. Yeah, interesting because we're calling the fit method inside of the fit, anyways. We're just adding extra functionality to it.
So just from the furthest view, fit functions, what do they do with the data versus, what does transform do with the data?
As you see, there are basically calculations that you're making. Right? So you're doing like a mean, you're doing a standard deviation. So basically, you're how can I say this? What do? You gotta.
Is the fit doing like the standardizing that we
Yeah.
talked about?
So basically, what fit does is basically it whatever data you have, it basically just fits in such a way to check whether there is no variation it is bringing. I mean, basically, because what all these operations are doing, you're basically checking that even if you transform the data, it doesn't like bring in very high variation. But fit is basically just trying to fit and see if it are not making the variation, and transform is basically actually transforming them.
Right. So you're making sure there's no variation within your data set by
So it's
using
always
it.
a two-step process whenever you transform a data into a data. First, you check whether you after transform, you see if it's not like bringing any variation, or it's not like changing the distribution of the data. But at the same time, then after you're sure, then you basically transform the data. So I think fit and transform kind of goes hand in hand. So usually there is just one function usually which does the fit and transform, fit underscore transform. I think, but like lot of functions with fit, separate, and transform, we can actually fit and see what the result comes out, and just transform what the result comes out.
Or
It
you
can
could.
be self in fit. Basically, it is just creating the model. It's not exactly transforming anything. In transform, I think it's using that model.
Right.
So essentially,
Looking
fit
forward to
function
the
is creating the k-means model, and it's basically, I think it's fitting the model, but just to like, so transform is actually like transforming the data, because like transform doesn't like you need to transform the data in such a way that it basically aligns with the like it works with the model. So fit
Yeah.
basically just like fits that model, makes that model, and then transform basically uses that model to transform the data.
Yeah. So, what did you say about the fit? the fit method does again? It's just basically making sure that there's no variation within the data set.
Yeah,
That way,
I'll just let me check exactly. Let's see what. As far as what I know, fit model is basically you just fit the data on the model and just see how the model is performing. Like, but you can
right,
still like once you fit the data on the model, you can still see how the model like provides the output. Like how accurate is the model. And I think transform is basically transforms that data as per the fitted model.
right, as the name implies. So,
Yeah.
yeah,
So because your data needs to be transformed such that it is suitable for the model. And how would you come to know that it is suitable? Is basically once you fit on the model. So you need to first fit the model with the data and then transform the data as per the model which is suitable. Usually that's the process.
okay, right.
It'll be interesting if we get to it. Is there a graph related just to
Yeah,
help us
I
remember
was just
fit,
checking.
what is
I was
fit?
just checking that how to
Just on
see
the
like
most
the
basic level, yeah. Before fit, after fit, visualization.
Right.
Mm-hmm.
So you're fitting in the data, and then after you fit the data for the model to like make it work even
you
better,
can actually
and
click on summary of the model. So just run the fit function. Like you should be able to see like summary on the model. So I'm just checking like if we can separate the fit because now just run dot fit of that create an object. You created object. Right? So why is it fit underscore transform? It should be just fit, right?
well, fit underscore transform is basically using the fit method first and then the transform method.
Oh, okay. So that's how. Yes. Can you can you just run like fit, just fit and like how just see the summary of the model. Just wait one minute. Just call the fit function of that. Like just see the parameters as like what that fit is expected. Just see those.
Of cluster simil.
Yeah. Plus cluster. You don't need to do like. I think just do like model equal to cluster sim dot fit because you don't need to do print that. It's not a sim. It's a model. So assign it to a variable. Don't do print. Assign it to a variable like model equal to like model equal to that cluster dot fit. Just when you go up, just see like what its parameters are. I just want to see like
And you want me to
when you go
print?
up, yeah,
You want me to print the model or what?
we need to print the summary of the model. So this fit, there are some parameters. So you need to put those parameters. So you can go up in the what parameters in the fit, and then
Housing.
yeah, latitude longitude. Yes, housing. Just say housing latitude longitude, and sample weight is equal to housing weight. I think copy the same thing what you did for fit transform.
Right here.
Yeah,
I looked up
I think
a little definition here. Model fitting is a measurement of how well a machine learning model adapts to data that is similar to the data on which it was trained. So it's
summary of the model. You need to put the summary of the model.
Model dot summary.
No summary or I think it's let me check what the function is. Fit model dot function summary of the model. Why is it there's a function, but I'm not sure if it's dot summary or summary of. I'm just checking. Yeah, model dot summary. Model dot summary and it's a like parentheses. Yeah, let's see what it says. Should be okay.
Has no attribute summary. Yeah, because this is a custom class though.
Okay. So I think it's not returning. I thought it's returning some kind of a fitted model. I thought, but it's not returning a fitted model. Okay, like yeah, I understood like what you said. Like PH was the one who done a perfect job. Like someone explained the definition right now.
I think that was Sweeper, right?
Yeah.
What did you say? You got a definition? What did your definition say?
Someone explained the definition like why like what's exactly fit in the model.
It's
So
basically to,
Yeah.
it's like to adapt to your model's.
how well the data adapt to the basically how
Yeah.
well the model fits over a data. Basically.
You know, I put a little visualization into the chat. And I'm sorry, I've missed a few meetings.
Yeah, right.
So
Right.
fit is basically
Correct.
the
That's
drawing of the line. Fit is like what does the line come out to as you apply your model that tries to interpret, you know, the X's from the O's.
Yeah. So
You know,
basically, it's basically interpreting the data, and trying to adapt with it. So that's what fit does, right? So
Yeah, I'm thinking like cluster similarity. Basically, to form clusters and kind of combine those like like
and when
like close.
right when you talk about clusters, you mean like grouping the data.
I mean, k-means clustering is that on these days, right? K-means clustering is basically using the k-means like the distance basically combines the points into groups, forms groups, forms clusters.
Right. Okay. So what we're looking at right now, this overfitting is kind of like clustering the data.
No. So the difference, the overfitting and underfitting is a bit different from clustering. I mean, it has nothing to do with specific clustering. So basically, the overfitting way is so like when you so overfitting. So let's say you have a point. Okay, you have a lot of points like you can. So
Yeah.
overfitting is basically what you do is you try to make those curves like so like basically your curve would be like exactly covering those exact boundaries without any variation. Like there won't be any like exactly covering. Sorry, there would be like very high variation because like if you see that graph, it's basically the curve is very like properly like following the gaps between the
Yes.
clusters.
Right.
So that's basically overfitting. Now that is like you say like that's kind of like a good model like in terms of bias, but it has a lot of variance because now the if you calculate like the mean and you can if you calculate the mean of that set of points and if you see the distance between all those points from that mean, it will be very variant. It will be very high low. Like
It
it
will be
will be
biased.
high variable. Yeah.
Right. Okay.
So that's overfitting. But in underfitting, you basically just try to draw a straight line. Like you just don't worry about like how well it is fitting, basically. So that won't like bring in variance, but that will like reduce the variance, but that will bring high bias. Also low bias. Sorry, yeah. It's low bias and high variance, and high bias and low variance.
Right.
So that's underfitting and overfitting. You need to find a sweet spot between them. That it shouldn't be the variance shouldn't be too high and the bias shouldn't be too high. So it should like balance. You have to find the sweet point for variance and bias, and that's the perfect fitting for a curve. I won't say perfect, but a good model basically. So it's not too underfitting, it's not too overfitting. Like
Finding
uniformly fitting. Finding a
finding
sweet spot.
sweet spots. Yeah. So that's what we're trying to like do right now. So we're implementing this fit function that basically tries to best approximate like a sweet spot where there's a little bit of variance and then there's a little bit of bias into it.
Correct. Yeah.
Okay, makes sense.
Yeah.
here's another a bit of fit method trains the algorithm on the training data after the model is initialized.
Can you
Mm-hmm.
repeat that again? What was it? The
The fit
yeah.
method trains the algorithm on the training data.
Right. Yeah, I can see.
So you're actually using the traded data. I asked another question here. I said, what would happen if we only used transform and never used fit? Like, what would be the repercussions? And two things that stand out to me is just uninitialized parameters. So for many transformers, the fit method calculates and stores parameters that are essential for the transformation process. For instance, in a scalar, which we've covered a little bit, fit computes the mean and standard deviation. So it's actually giving you information about the data set. Without these parameters being initialized through fit, the transform method might not know how to scale the data. So it essentially generates data that you need to do the transform. Without the fitting, you're not going to have the data that you need to do the transform. And then also down here on loss of integrity, it says the purpose of fitting is to adapt the transformation to the specific characteristics of your data set. So you're learning about the characteristics of your data set by doing the fitting, which allows you to make the transformation. Without this step, the transformation process is blind to the data's properties, leading to potentially inappropriate or misleading modifications to the data. So if you don't fit it, then it's not going to transform properly. You're going to learn from the fit about the data, enough data to make the transformation an accurate transformation.
Yeah, so standard deviation means basically variation. How how varied are your points from the mean? So you need mean and standard deviation for every parameter and see how varied are your points from the mean. So if it is too varied, then like so that's why the transform function uses that variance for every parameter and finds the sweet spot and then transforms scales the data in such a way that it doesn't bring it ready
Right.
begin anyway. So it doesn't like reduce the noise.
Mm. Yeah, that all makes sense.
Make it less noisy. Make it less noisy and make it better to work with. Therefore you transform.
Cool. All right, so you could check whether your custom estimator respects Scikit-Learn's API by passing an instance to check estimator from the Scikit-Learn utils estimator checks package. For the full API, check out that link. As you'll see in Chapter 9, k-means is a clustering algorithm that locates clusters in the data. How many it searches for is controlled by the nClusters hyperparameter, so you could actually set how many clusters you're searching for. After training, the cluster centers are available through the cluster centers attribute, so you can find out how many there are. The fit method of k-means supports an optional argument, sample weight, so you could pass an extra data to this one, which lets the user specify the relative weights of the samples. K-means is a stochastic algorithm. Does someone want to Google stochastic? I'm just curious about that. Meaning, or
Stochastic means basically if you run that same algorithm, let's say 1,000 times, you won't get the exact same result. You will get similar results close by. So it basically gives you like different results for different runs, but
It's
that
random, right?
yeah, you find basically a range of that. So basically if you run 1,000 times, then at the end of 1,000 simulation, what you'll get a band, a range, a min and max, and that way you can tell that the solution lies between that. You cannot exactly tell that this is the optimal value, but you can say that there is a band of range of solution, and the solution you can be sure that the solution lies within this range. So that's what you can.
okay, cool. Meaning that it relies on randomness. That's funny because they're literally describing what it means now. To locate the clusters. So if you want reproducible results, you must set the random state parameter. Okay. As you can see, despite the complexity of the task, the code is fairly straightforward. Now let's use this custom transformer. I already typed out that code right here, so I'm just going to go ahead and keep reading, but I'll leave it in view for those who want to type it out as well. And feel free to look at my code here. This code creates a cluster similarity transformer. setting the number of clusters to 10. Then it calls fit transform with the latitude and longitude of every district in the training set, weighting each district by its median house value. The transformer uses k-means to locate the clusters, then measures the Gaussian RBF. What is it?
Radio basis function.
Radio basis function similarity between each district and all 10 cluster centers. The result is a matrix with one row per district. So one row per district and one column per cluster. Let's look at the first 3 rows, rounding to 2 decimals. So let me go ahead. Similarities. 3. Round 2. All right, so we get that. I actually want to see this graph though.
So it's sparse matrix.
Yeah, so show that's interesting.
Not that, because the same plot we had done above is like somewhere. So we can plot it, but like to kind of make it the same plot we have done above it. So pretty similar. Yeah.
This one?
Yeah. It's pretty similar, but you just need to like make sure that you like write like in this case I think what should be like the similarity function.
Oops. So kind, scatter, longitude, latitude, true, population.
Cluster plot, right? Cluster plot this is scatter plot, but it basically is like it's a heat map. So in case of the heat map, you add you have added steam map. Yeah, the steam map is like that basically like there's a steam map parameter. Right?
Oh yeah.
Yeah, I think that basically defines it as a but in this case change your housing population similarity.
Right here.
Oh no. Okay. Yeah, this plot is actually not the similarity. This plot is housing population.
Yeah, housing plot.
Yeah.
Similarity.
So it's no, I don't think it's similarity. But yeah, it's not similarity. It's actually housing plot only the way you did it. Can you just run that same command again? Housing plot.
I mean, if the question is why aren't we seeing it, I think you got to go up and sort of run, a lot of the things that, it's like every time you open this up, you kind of got to run each
I think
thing.
we ran it.
Let me see.
I have run it.
Yeah, I have run it. I've run everything up above, but I'm still getting an error because I don't think we have access to the same. Because we've been changing the data so many times, we're not using that same data anymore. We're using different data at this point. Let me see if this works because this I just asked it to do this real quick. If it doesn't work, that's fine. We can keep moving, but let's see how well it did it. Nah, no way. All right, I don't want to. I'm gonna actually just add some text here, and I'm gonna say figure out.
Well, it does kind of do clustering, but in a different like kind of graph.
Yeah. I'm gonna figure that out.
I mean, it is using heat map. So it's basically doing clustering, but it is using heat map. So the points which are far away are basically blue, but the points as it gets in, the color changes. So it's a heat map.
Yeah.
All right. Well, we can see it. We can see it here. Yeah. Exactly. So you can see where the most highly populated areas are, basically. All right. So transformation pipelines, as you can see, there are many data transformation steps that need to be executed in the right order. Yes, that is clear. That's like 90% of the chapter, I feel like. Fortunately, Scikit-Learn provides the pipeline class to help with such sequences of transformations. Here's a small pipeline for numerical attributes, which will first impute, then scale the input features. So,
Ooh, that's a lot. It's a lot simpler. Oh, why didn't we just do this?
I know. Well, that's what they did with the functions where we had to create the training and the test set. Like we saw the crappier versions of it, and then they showed us better ways of doing the same thing, essentially.
Yeah.
I mean, the thing with imputers is like, uh, so the problem with these is like, so that's something like I usually don't like. You don't have the control. Like,
Yeah, you don't
you
have the
just
control.
so the thing with like when I feel like the above code which they show, that gives you more control to understand exactly like this something what you're doing now is basically just machine learning. The above part is statistics plus machine learning. And in the real world, it actually goes with statistics and machine learning, not just machine learning.
Yeah.
So, like this part is pure just machine learning. If you just want to like, it's like your manager tells you, okay, do this, use an imputer, you just use it. like, like you won't exactly see like why do you need an imputer? Like why you're using a median statistic?
Yeah.
Like why are you not using a mean statistic? And everything. So
Yeah.
all those factors comes into picture because this doesn't give you the clear idea of why you. I was thinking of starting to like read about why what exactly is an imputer and like is there any way to like check whether the imputer is going to work on that data or not?
Right.
So I think the above part makes sense when you are actually like working on a project. This because they are like guiding. But when you will actually start a project, I feel like we have to actually see the statistics behind it and to exactly analyze like how is the variance going, how is the standard deviation going, what's
Right.
going on.
Looking at the black box. Right.
Yeah, everything.
Yeah. Yeah. True. I'd rather at least. I'm not saying that this is a bad way to do it, like if you're just doing the machine learning without the granular details, but I think in the beginning, to really understand what you're doing, I think the granular details are important for sure.
True, true. I mean, this definitely will work, but I feel like when you're using a imputer, there should be a way to see like what the statistics of that imputer. Like when you run this, there should be some statistics of that imputer saying that okay, it is giving you like 10 like 90% accuracy or 80% accuracy when you fit the model after the imputer.
Yeah.
There should
Yeah.
be some metrics to every operation what we do.
For the pipeline, yeah.
I wanted to ask. There's a couple people who just haven't been chatting that much. Emmanuel, Andy, Supreeth. Do y'all have any thoughts or questions on any of this stuff here? Do you understand it? Is it kind of going over your head? What's going on with you guys?
Oh, sorry, I just
Supreeth?
Yeah, so for me, I'm trying to understand like these. I've heard these terminologies before, but I didn't get like proper understanding before. So I'm trying to take it slow, and I kind of missed the first class. I mean, this is my first class here, right? So I think I need to brush up the first chapter first, and then come here. And at the same time, I'm like trying to understand what's going on. I think, yeah, good.
Cool. Yeah, I have the previous sessions recorded. If you don't have the book yet, you could go ahead and watch through those, and we're reading through the book in those sessions as well. But yeah, besides that, it's just yeah, cool, awesome. And then Emmanuel.
yeah, same here. This is my first time connecting, so I need to catch up.
Cool. All right. Yep. I'll go ahead and share a link after the event just so you guys could get caught up if you don't have the book yet. But I would definitely recommend going through O'Reilly or just getting a copy of the book. It's the go-to. It's the standard in the industry for machine learning. So this is definitely the book to go with. All right. Cool. So the pipeline constructor takes a list of name estimator pairs, so 2 tuples, defining a sequence of steps. The names could be anything you like, as long as they are unique and don't contain double underscores. They will be useful later. So we did impute and standardize in the last example. They'll be useful later when we discuss hyperparameter tuning. The estimators must be all transformers. They must have a fit transform method, except for the last one, which can be anything, a transformer, a predictor, or any type of estimator. In a Jupyter notebook, if you import Scikit-Learn and run Scikit-Learn, set config display equals diagram, all Scikit-Learn estimators will be rendered as interactive diagrams. Ooh. Okay, that would have been really helpful in the beginning. This is particularly useful for visualizing pipelines. To visualize num pipeline, run a cell with num pipeline. As the last line, clicking an estimator will show more details. So if I go ahead and do that in this one here, I should see it. What is it saying? Import run scikit-learn sklearn.set config display.
Should it be after the numpy, or should it be?
After this?
Yeah, should it be? Or
I don't think so. I think it says if you import scikit-learn and run scikit-learn.kit, so. Huh. Scikit-learn.set. Let me see if I could. That should be good, right?
yeah, that should work. Or just remove sklearn and just say set config.
Set config. Nah, because the set config is a method on this, isn't it? It says just import. It's all good. I do want to see it as a diagram, though. I'll figure that out. If you don't want to name transformers, you can use the make pipeline function instead. It takes transformers as positional arguments and creates a pipeline using the names of the transformers classes in lowercase and without underscores. Let me just type this. If multiple transformers have the same name, an index is appended to their names. So it was just tack on a number to the end. When you call the pipeline's fit method, it calls fit transform sequentially on all transformers, passing the output of each call as the parameter to the next call until it reaches the final estimator, for which it just calls the fit method. So this pipeline thing is just if you want to run the same transformations on multiple sets of data, basically, right? Same way we create a function, we just want to reuse it multiple times.
Yeah, just in a generalized way, right?
Yeah, okay. The pipeline exposes the same methods as the final estimator. In this example, the last estimator is standard scalar, which is the transformer, so the pipeline also acts as the transformer. If you call the pipeline's transform method, it will sequentially apply all the transformations to the data. If the last estimator were a predictor instead of a transformer, then the pipeline would have a predict method rather than a transform method. Calling it would sequentially apply all the transformations to the data and pass the results to the predictor's predict method. Let's call the pipeline's fit transform method and look at the output's first two rows, rounded to 2 decimal places.
So the thing is, Jim, like what I've noticed till now is all these operations we are doing, we don't have to do them when we actually work on the project. Not all operations.
Yeah.
So the thing is, these sections are kind of independent sections. So I feel like uh, when you actually complete this entire section, try to like give like a topic to it, like a section. So initially the section was just cleaning the data and pre-processing. Now the 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 session is basically fitting the model much better.
Mm-hmm.
Then the next one is training the model. I feel like fitting the model is the longest one. We're trying to like do a lot of stuff to like see how well the data is fitting, and if it's not fitting, it is transforming, right?
Yes. Yeah, that makes sense. Yeah, this definitely seems like the largest section. Um,
Yeah, it's just we are trying to it is trying to show us multiple techniques how you fit up.
yeah, because there's tons of different ways to do it. True, true. But I feel like it's still not covering everything. Like, there's still way more at the end of the day. As you saw earlier, what's up?
Yeah, so you're right. It's not exactly covering everything because
Yeah.
the thing is, I feel like this session we already knew that it's kind of a high level. It's not a low level session. It's not going to like it's just giving us a kind of like so I read about online what this session does. It's end to end. This session is just about kind of just letting us what a machine learning engineer does in his day to day on a project.
Yeah, yeah.
That's what this session is about. Just what a ML engineer does in his day to day job. So
Yep.
we don't have to exactly like in depth understand just like a overview of what exactly is being done. Like the sections we talked about. First section was pre-processing the data. Second one was fitting a model. Third one was training the model. What we'll do.
Mm-hmm.
So you can see like fine tune is basically what we are doing. No, no, no. Yeah, we are doing as to prepare the data for machine learning. That's what our process is. But it's basically like yeah,
Yeah.
transform pipeline.
Yep.
So I feel like these sections are what like a machine learning engineer does in his entire day-to-day life on a project. But it's like I feel like this would I mean we can just go through it, but next book when we'll start, that's when I think it's better to go in depth and understand this.
Mm.
Where are we exactly right now?
We're right here.
Selection. Okay. Transformation pipelines.
Yeah.
Yeah. Yeah, I mean, when we get to classification, I believe there's a new
That would
project.
be like like so we'll understand like so now we are using regression. For regression we are saying that these are the parameters, these are the transformations. But when we'll actually go in depth of every machine learning algorithm like classification, then we'll understand what stuff needs to be done in classification.
Mm-hmm.
what all fine tuning we need. That would give us like a low level understanding of the.
Yeah, yeah. Are you saying that we don't have to type all the code, or are you just like in general just making
No,
a
no. The
obs?
type of the code, like typing is important, like because you get a hang of those functions.
Yeah, yeah, yeah.
Because these are the same functions which you get used. But I'm saying that if someone is like completely stuck and not able to proceed with that concept, not able to understand, I'd say we don't have to like wait for it. I mean, we can just get a high level of what that concept is. But when we proceed in the next chapters, we'll try to get in depth of it.
Yeah, yeah, yeah. I got what you're saying. No need to really go deep into the concepts, but just like understand it
because
on a
this
high level.
right, because this is an end-to-end like machine learning project, and we haven't really gotten into the full like in-depth topic of
I mean,
like what
basically,
is
I'm hoping that you basically have like 2 hour tutorial YouTube video for the entire event, and you will be able to cover everything about machine learning. We can't expect that.
right.
Well, also with this stuff, like I'm planning to go back through this chapter anyways again. Like I wanna go through like from the top to the bottom, and anytime I encounter like even pipeline. Like I don't know exactly what this means on a deep level. And you say pipeline, but pipeline means multiple different things in multiple different contexts. So I want to understand those multiple different things in those multiple different contexts. So like on my own time, I'm definitely going to be digging deeper into different vocabulary as well. I'm going to go through this whole chapter again, not looking at details, but only looking at words that I can't describe. If I can't say it, articulate out loud what this is, I'm gonna go down a rabbit hole and really understand it on a deep level. That's just me though. Not everyone has to do that.
Yeah,
Yeah,
that's a good way to do it.
I'm going to do the same thing. Like I'm going to look at that again and try to at least get clear with concepts which I don't like. I'm aware of some things, but some I'm not aware of. So I want to understand what is the book.
Yeah, yeah.
And the best is when you can get a picture to go with it.
Get a what?
True.
Get
When you can get a picture to go with the definition, the concept,
You
to
need a big picture.
visualize it.
Yeah.
Yeah, yeah.
Yeah, and then stats is all about visualizing.
Yeah, you're right though. If you could yeah, get a picture or create a picture that goes along with it, that even is better for learning.
Hello, can you guys hear me at all?
Yeah.
All right, I got it. This is Andy. I got on at the beginning of the call. I've been following along with you guys here as well as trying to get this audio back up over here.
Cool, cool.
I wanted to ask, is this is the third version of the book?
Yes.
Okay. I got the second version. It's not following. It's not. I can't seem to find where we are in the second book. Is there a page number or anything like of what you're on right there?
I don't get page numbers because I'm using O'Reilly. Yeah.
There
This
are
is
links.
chapter 2. This
There are
is
links.
chapter 2 of the book.
Say that again.
Is this chapter 2 of the book?
Chapter 2, yes.
Okay. Is that a header down at the bottom, chapter end-to-end machine learning project? Is there like any header you can scroll to just in the text so I can try to align with what I'm looking at here?
I know we're in the prepare the data for machine learning algorithms section, and specifically the transformation pipelines. Yes.
Prepare the data for machine learning algorithms.
Yeah, you have that.
Here in the custom transformations.
No, transformation pipelines.
Go into the resources section and you'll find a link to the third edition of the book.
In the resources section of what?
I think it's in the of the Discord. And there's a link to the third edition. You can click on it and it can be right on the page here.
I'm sorry, I didn't follow what you were saying. Go to where?
In in the Discord,
Uh-huh.
and I'm going through myself. Actually, if I can step out of full screen mode, I think it's in resources, and
Resources.
I think there's a link to the third edition of the book. I have to.
It's under projects. If you go to projects, yeah, there's like a link to the third edition of the book back in June the 3rd.
Okay, so scroll up.
Yeah, exactly.
Scroll up.
Exactly.
June 3rd.
Yeah.
I'm putting some emojis on it that would stand out. Yeah, Kenny J, not G, has got the links to the third edition of the book.
Yeah, we'll stop right here. We'll stop right here, anyways, because we got about 5 minutes left. So feel free just to find that copy right there.
I've posted the link in the chat if you didn't find it.
All right, that's the third edition right there. Excellent. All right, and so basically that's where we're at. You guys are at basically in chapter 2, transformation pipeline. How far you've gotten so far.
Yeah, that's
And
good.
this call is when now? It's Friday, Saturday, Sunday, or something?
Yes.
Okay.
Yep. Friday, Saturday, Sunday, 6 p.m. to 7:30 Eastern Standard Time.
I have a question. Next Friday, it's gonna be a meeting because of Thanksgiving. I was asking.
Friday there will be, yes, but Thursday I'm canceling everything. Yep. Yeah. I'll be with my family on Thursday, so I just can't do any events. But yeah, if it's not like Thanksgiving or Christmas or one of the big holidays, I'm gonna be here. So. Yeah.
And then these books that the Jupyter notebooks that you're working through right there on your desktop, you are basically just taking this from scratch and working through the text of the book and writing this stuff out?
Yes. Yeah. Yep. Simple enough. And then, like Aditya said, this is an end-to-end project. There's a lot of code that we're not actually using on this project. It's just kind of teaching the concepts. But when we get to the chapters like classification and neural networks, I believe they're more like the code included in those chapters is the code being used for those projects. So we'll see when we get there, but that's what it looks like.
And you're posting these on the meetup then. Okay, so do you need to like RSVP for each one of these?
No, you could just show up. Once you're in the Discord server, you could just show up.
Okay.
Yeah, so I'm going to post all the events at the top left here. We have an events section, and then after every event, I go ahead and I post a recording of the session in the machine learning channel. So if you can't see the machine learning channel, just go to the choose a specialization channel. And in there, you could just click on the brain. There's about 40 people who have clicked it so far, and then it'll unlock the machine learning channel for you, and you'll have access to all the videos. So you could get caught up if you missed any.
Okay. I'm not familiar at all with. I'm familiar with what the example you're working on right now in the book is. I'm very familiar with it. I am completely clueless about this Discord thing. Is this your own server or something, or what is this?
Yeah, I'm still learning Discord too, so no sweat on that. It's basically all the servers are on the left here. Like as you join a new server, they'll show up on the left here, and then when you click between servers, all the channels will show up here, and then when you click a channel, the content of the channel will show up in the middle. So it's simple. It's simpler like once you get the hang of it, but if you're new to it, I remember it was like just trying to figure it all out was a little challenging. But once you get it, it's really, really great.
And so this is your own server then here. So you've got this other, and I've seen some of your meetup posts before, web development, this data structures. I take it in there you've got a book that you're working through. Is it the same format of what you're doing here this evening?
No, the data structure algorithm events. I do trainings Monday through Thursday for data structure algorithms, and then we have a data structure algorithm on weekends, and then I do a coding boot camp as well for web development. So, yeah, this is the only book club. Yep.
May I ask, who are you? You've got, I'm looking at this here, you got multiple classes running. I'm sorry, are you a trainer or something?
Yeah, you could call me a trainer. I mean, I don't have any professional experience in the industry. Most of my experience is in sales management and business development in the solar industry. But I started coding back in 2017 and started really taking it seriously when COVID hit. You know, I was looking for an in-person meetup and I couldn't find one anywhere, so I just created one, and it started off slow, but it grew week after week, and eventually it was just like we couldn't even fit at the Starbucks anymore. We had to find a bigger location, and we started, actually one of the members of our in-person meetup was like, dude, start a Discord so we could stay connected during the week. It's 24/7. We could have like virtual meetings, and we started just doing like data structure algorithm contests on the weekends, and it all just stemmed from there. So it's been cool. It's been fun. It all just started with I was just trying to find an in-person meetup and I couldn't find one anywhere. So I just started my own, and yeah, it's blossomed, and I love doing this stuff, you know? So I'm a little, I don't know if I ever want to like work in the industry because, well, like for a company, because I feel like if I'm working 40 or 50 hours for a company, then like I come home and be like, I've been coding all day. I don't want to code anymore. And I love this so much that I don't want to risk that. But yeah, it's good. I love it. Yeah.
Now you're worldwide.
Yeah, you're worldwide now. Now, where are you located at? Is Jim? Huh?
Yeah. Yep.
Where are you, Jim? Where are you?
I'm in Connecticut.
Okay, Jim, Connecticut. Okay, so.
Yeah. How about you?
I'm outside of Chicago. I'm 50 miles directly west of downtown Chicago.
Okay, cool. You been in the industry for a while, or?
Yeah. I'm an electrical engineer, computer engineer, CS degrees. I've done telecom most of my life, and I've been playing with this stuff. I've been on the Python trail for the last, 5 years, messing around with that Python. And I've been through several of these, done, the third edition of this book. It'll be fun to run through. Let's see what it's got. And my problem is I do so many different things that I forget them all. You know what I'm saying?
Yeah, totally. Awesome. Well, welcome.
Cool, thanks. Sorry about the interrupting here. I finally got the audience. I'm going, what the hell? Why is this not working?
Yeah, no, you're good. The interruptions are welcome for sure. And we're just finishing up the event anyway. So, yeah, if no one else has anything else to chime in, we will. Our next event, I'm actually launching a couple new events tomorrow. So, tomorrow we're launching. Most of the people here wouldn't be interested in those. But, yeah, if you're interested in any of the, like taking a look at the other events, just keep your eyes peeled on the events at the top left.
So the login, let me ask this, and since I'm so unfamiliar with these Discord things, the login and password that I used here is really just for this particular Discord channel, which is yours?
No, the login that you use for Discord is for all of Discord. Yeah. So you'll be able to, like, there's tons of other coding communities too. So you could find, like, once you get comfortable with Discord, I'm sure you'll have like 10 different servers on the left that are all just like communities of coders that you fit in with. So yeah, it's cool. Yeah. Feel free to reach out to me anytime if you have any more questions too.
All right, thank you.
Yeah, for sure. All right, everyone. Have a good night. Thanks for popping in tonight.
Thanks, Jim,
Thank you,
for
Jim.
running this.
Yeah, for sure. See ya.